morning. Thank you all for joining us. If you have any questions or comments, please feel free to put them in the chat. And it is 8:30 and I'm going to be conscious of time. I also want to mention that Kristen Connolly, CEO here at the East Bay Leadership Council, is here and on the line. And Gary, I see that you're on the line as well. Can I turn it over to you to begin?
Okay, can you hear me?
Yes, we can.
Great. Well, thank you very much. Thanks for joining the Water Task Force. Since the last time we met, we talked, a lot about the pandemic that's going on and the impacts that it's had to your organizations. Had a great presentation from Eileen White, and we get to welcome her again today. Thanks for attending. We have a great lineup of speakers for you today, and Dave Richardson has lined all of this up, and he will introduce the speakers and the topic in a moment. The one thing I would point out, in terms of water, this year appears to be a normal year from a hydrologic standpoint, and so that's a good thing. And we have a goodly amount of storage in our system, so at least from a water standpoint, we're in pretty good shape. Since the last time we met, we talked a little bit about it. Would there be a water bond on the ballot this coming November? And at the time, it didn't seem like it, but the Assembly has passed a measure. It's Assembly Bill 3256. They passed it, or they have classified it as an urgency measure, so it takes a 2/3 vote in the full legislature to get onto the ballot this year. It's AB 3256. The author is Eduardo Garcia, and it's called the Economic Recovery, Wildfire Reduction, Safe Drinking Water, Drought Preparation, and Flood Protection Act of 2020. It does contain in it, if it were to pass, $1.35 billion for water supplies in California, $1.6 billion for climate resiliency, a total bond amount of almost $7 billion. Does California have an appetite for that? I don't know. But nonetheless, it is something that it is going through committee, and the deadline, as I understand it, is June 25th for it to pass the legislature and to qualify for the November ballot. Lindy, do you happen to have any update on that?
I think you just did a fantastic job. Our understanding is that due to COVID, there's been somewhat of a reduction in the amount of legislation we've seen come through, and that this moved forward, as you said, somewhat as an emergency measure, but they're on a very short timeline. Working in the Senate. I know that you'd sent an email and there's some conversation about possibly giving some feedback on that. And I think that if we can get some of those notes that we might want to see passed forward done this week, then we certainly have an opportunity to possibly make some commentary there, but it's moving very quickly.
Okay, thank you. So I think the main thing is that's what we do know as of the moment. Several of the agencies that are on the call may have more information. If you'd either email that to me or put it in the chat section today. It is a bill that's moving forward, and we should pay attention to that. So again, we have a great lineup today in terms of a panel for you. And before we get to that, I would turn it over to Dan McIntyre to give us a preview of upcoming Water Task Force meetings. Thanks.
Hello, everybody. We've got a couple of great topics the next couple of months. In July, we're going to review the Governor's California Water Resilience Portfolio Initiative, and our speaker will be Nancy Vogel, who's the director of that portfolio program. And the whole idea there is to think more comprehensively on a statewide basis about how to address water demands and needs and limited supplies in a comprehensive way throughout the state. So kind of get away from at a philosophical framework level in the state of every water user and agency and environmental interest scrapping for water individually, but kind of look at things in a more comprehensive way. So that'll be fun to see what the governor's administration is developing. So that's July 21st. Then in August, related to that, we're going to dive in and do a review of the status of a number of California reservoir projects. So certainly those are a part of the water supply situation and storage situation throughout the state. We're going to review the Sites Reservoir northwest of Sacramento. We're going to review the Pacheco Reservoir expansion down in Santa Clara, and we're going to review the Los Vaqueros expansion in Contra Costa. And of course, we've all received one or more reports in the last couple of years about sites in Los Vaqueros, but things have happened since then. Obviously, there's initiative or Proposition 1 funding that's been supplied to those two projects, and we want to see how that state funding is helping those projects move forward, what's the status, and when they might be in line. The following month in September, we're tentatively looking at an overview of PFAS issues in water. PFAS are forever chemicals that have moved up on the public's attention and something we need to address. So we're trying to get that scheduled for September. And then looking forward ahead, we have well over a dozen other ideas in the hopper for some great concepts. If you have ideas or suggested speakers, things you've heard about that you'd like to add to the hopper for consideration, by all means, reach out to somebody on the planning team. People like me, Gary Darling, Dave Richardson, Dave Requa, Don Berger, Ann Spalding, Bob Whitley. Any one of those people can take your idea and present it to the planning team meeting. And if it's timely, we can move that up in priority and get that on the agenda soon.
Thank you, Dan. Gary, I believe I'm going to introduce Dave next, but briefly I wanted to mention that if anyone has any announcements that they'd like to share, please feel free to put those in the chat. Or if you want to just raise your hand really quickly right now, we can do that for a moment. Otherwise, again, please put them in the chat so that everyone can see them. And perhaps we will have time at the end to mention any specific ones that are timely or particularly relevant to this presentation. But the chat is a great way for us to keep track of all of that. Not seeing any immediate quick hands jumping up, I'm going to turn it over to Dave Richardson, who did a wonderful job working with Katie to plan this panel. We're really excited to hear from everyone.
All right, thank you, Lindy. Yes, welcome everyone. Katie Ruby is our panel discussion leader for the declining flows and its effects on water systems, wastewater systems, and recycled water. We have, as mentioned, a great group of folks that will be supporting Katie in this panel discussion, and Lindy and I will be monitoring the chat and will be helping to facilitate. Please feel free to mention a question that you have along the way in the chat, and we will try to take it up in a timely way. And then after the presentations are done, we're looking forward to a robust discussion among the group about the subject and really bringing in all the panelists. Katie, who has been our ringleader in putting this together, is a water resources engineer with Brown and Caldwell. She's also the Deputy Executive Director for CUWA, the California Urban Water Agencies, which is a nonprofit corporation of 11 major water agencies that collectively serve drinking water to 2/3 of our state. Katie is originally from the East Coast, moved to California in 2015, is now captivated by California water, and you're in good company, Katie. She has spent the last 4 years working closely with water agencies in California, spanning the water management arena. She works closely with the executive director and the CUWA board, and she also has a Bachelor of Science degree from Duke and a master's from Stanford, both in civil engineering. So with that, Katie, I'll let you introduce the topic and your speakers as we go. Thank you.
Great, thank you. All right, I'm gonna go ahead and share my screen. All right, can everyone hear me and see my screen okay?
Yes.
Okay, great, thank you. Thank you, Dave. Yeah, so today's discussion, as he mentioned, will be on declining flows, specifically the unintended consequences of conservation and long-term water use efficiency on kind of the whole interconnected urban water cycle. And as you all know, drought is a recurring phenomenon in California, and with climate change, we expect drought will likely become even more extreme in the future. So with that, demand management will continue to be an important part of our water supply reliability strategy. That said, it's important to recognize the impacts of declining flows so that we can wisely manage our systems accordingly. And of course, there are impacts here or implications here for state policy as well. as the state is currently in the process of establishing urban water use objectives, which will include indoor residential water use standards. So as Dave mentioned, in addition to my role with Brown and Caldwell, I also work with the California Urban Water Agencies, or CUWA. The 11 agencies are listed on the screen here, and they collectively serve drinking water to 2/3 of the state's population. And several of you on the line I know are representatives of CUWA, so it's nice to see you. CUWA aims to leverage the collective technical resources and voices of its member agencies to inform policy and really to speak with a unified voice on key issues. And CUWA supports a holistic or a one water approach to water management. So again, while conservation and water use efficiency are important, understanding how these strategies affect the full interconnected urban water cycle allows us to better manage our systems. And during the recent drought, CUWA agencies and many others noticed impacts from lower water use and wanted to take a closer look at how these affected a variety of water, wastewater, and recycle water systems. The intent being to share lessons learned with other utilities, as well as to inform state policy on water use efficiency. And I want to pause here to define some terms, as sometimes conservation and water use efficiency are used interchangeably. But here we differentiate between them. So conservation, we define as kind of short-term emergency reductions in water use, typically during drought. So things like taking shorter showers, whereas water use efficiency is a longer-term strategy for more lasting demand reduction. So things like swapping out your lawn for more drought-resistant landscape or installing low-flush toilets. And now with COVID-19, we're seeing kind of yet a new shift in water use patterns with heavy commercial areas or high tourism areas seeing substantial reductions in water use. So all this to say there's a variety of behaviors and water use practices that can cause low flows in our systems. And it's important for us to kind of understand these so that we can adapt accordingly. So back in 2017, CUWA developed a white paper in partnership with CASA, Water Research Foundation, Water Reuse California, and CUWA. It incorporated survey data and case study interviews from utilities all across the state to analyze the impacts of declining flows on utility systems and discuss how these agencies are adapting to new challenges. And then building on this work, last year we prepared another issue brief. This one was also co-funded by the Water Research Foundation. And the purpose was to explore a little deeper the implications of potentially lowering the indoor residential water use standards. So this kind of following the 2018 legislation that set a provisional standard of 55 gallons per capita per day. And that standard is going to kind of gradually ramp down unless the state deems that a higher, less stringent standard is more appropriate. And I know there's some speculation that maybe new legislation will come along saying a lower standard is more appropriate. So just wanting to kind of get ahead of that and make sure we're understanding kind of the indirect consequences of lowering water use. Both of these papers are available on our website at www.cuwa.org, along with a set of policy principles on this topic if you'd like to learn more. But today I'm going to give you a super brief overview and then leave it to our panelists to dive in more detail. But here, as you can see on the screen, our survey results showed that impacts from declining flows were experienced throughout all types of utility systems. So that includes drinking water distribution systems, wastewater conveyance, wastewater treatment, and recycled water. And the green bar here on the screen shows the % of survey respondents who indicated that they experienced negative impacts. So mostly in drinking water, also wastewater, and then followed by recycled water. And again, just a brief overview of these impacts as our panelists are going to go in more detail. In drinking water distribution systems, we saw changes in water quality, such as from difficulty maintaining a disinfectant residual. In wastewater conveyance systems, we noticed increased odors, corrosion, and blockages. And then, of course, that affects the wastewater treatment plant influent water quality as well. And then sort of rounding out the cycle with recycled water, we noticed changes in both quantity and quality of water available for reuse. And I should note too, a lot of these impacts are largely caused from reduced indoor water use because the plumbing's all connected. And so one of the recommendations that came out of our CUWA work is for policies to focus more on reducing outdoor water use, where there is still significant room for progress, but with less potential to have these impacts on conveyance and treatment systems. All right, so now you'll get to hear from the experts. We're lucky to have 3 panelists from CUWA member agencies here today, each kind of representing a different part of the water cycle. So they're each going to share from their own experiences, and then at the end, hopefully we'll have plenty of time for Q&A. And I'm going to pull up their bios and introduce them here. Okay, so Mike Wickham, Water Production Manager for Alameda County Water District, is responsible for surface and groundwater treatment, water distribution system operations, water quality, and environmental compliance. Mike has over 21 years of experience in the water industry, including working at Contra Costa Water District and East EBMUD in the areas of water treatment, water transmission and distribution, and security and emergency preparedness. And I know he's represented on CUWA's Emergency Operations Committee that we convened kind of in response to COVID-19. Mike has a bachelor's degree in business management and holds a T5 water treatment operator and D4 water distribution operator certificates with the California State Water Board, and is a BCSP certified occupational hygiene and safety technician. So Mike is going to kick us off on the water side, but I'll go ahead and introduce our other panelists as well, so you know what's to come. On the wastewater side, we have Eileen White. She spoke at last month's Water Task Force meeting, so glad to have her back again. She's the Director of Wastewater for the East Bay Municipal Utility District, East EBMUD in Oakland, which supplies water to approximately 1.4 million people and wastewater services to about 670,000 people. Eileen has more than 20 years of engineering experience in the wastewater, water, and power industries. As the Director of Wastewater, she's responsible for leading the wastewater department, which includes planning, organizing, and leading the engineering operations and maintenance of the wastewater systems to ensure efficient operations and meet all of the regulations. She also manages the lab, which provides analytical support. And prior to this role, she was manager of water operations and chief operator for the district for 17 years. And was responsible for managing the district's $189 million seismic improvement project. Eileen has a BS in civil engineering from Berkeley, is a registered PE in California, and has a water distribution operator grade 5 certificate. And then Florence Wedington's going to round us out on the recycle water side. Also with East EBMUD, Florence Wedington is a senior civil engineer in the Office of Water Recycling. She has over 20 years of experience in the water, wastewater, and recycle water industry, and she's been with East EBMUD for 17 years. Prior to that, she worked as a consultant, and her current responsibilities at East EBMUD include overseeing and leading East EBMUD's efforts to develop and implement the water recycling program. She holds her bachelor's degree in civil engineering from UC Berkeley as well. All right, and with that, I'm going to turn it over to Mike to kick us off on the water side.
Hello, good morning, everybody. I'm going to talk about the Alameda County Water District, and we'll start with a brief overview. My presentation is going to focus mostly on the operational and water quality impacts of declining flows for our treatment facilities and distribution system. So we are a drinking water provider. We provide potable water to the cities of Newark, Fremont, and Union City. And our customer profile, we're mostly residential, we're about 70% residential, and then about 16% business, about 10% industrial, and the rest is institutional. So, next slide, please. So we have multiple sources of supply. We get our water, we have surface water from the State Water Project, which we treat at one of our treatment plants, so water treatment plant number 2. And then we also have groundwater from our Miles Cone Basin, which we blend with purchased water from the San Francisco Public Utilities Commission. And we also, from that, the basin, we also treat brackish groundwater in a Newark desalination facility. And additionally, we can supply water from the San Francisco Public Utilities Commission directly to our customers through some direct takeoffs. Next slide, please. So for water production facilities, when the drought began, we had 4 of them. Now we have 3. And that was one of the major impacts that we had during the drought was the decommissioning of a treatment facility. But for an overview of facilities, we had 2 surface water treatment plants, our water treatment plant number 2, and then our Mission San Jose water treatment plant. The water treatment plant number 2 is a conventional water treatment plant, and the Mission San Jose water treatment plant was an ultrafiltration water treatment plant. They both treated water from the South Bay Aqueduct, so a delta water source. And then additionally, we have our blend and the blending facility again, which just blends our production well water with purchased water. And the blending facility has a capacity of about 45 million gallons a day of production, whereas our surface water plant, water treatment plant number 2, has a capacity of about 26 million gallons a day. And then we have our desalination facility, which treats brackish groundwater from our aquifer reclamation program. That has a capacity of about 12.5 million gallons a day, maximum capacity. Additionally, we had, where we decommissioned it, the Mission San Jose water treatment plant, which treated about 8 million gallons a day. So pre-drought, with the higher demands, as you see the demands up there, our max day production and average day productions pre-drought were much higher than post-drought. So pre-drought, we had an average day production of about 44 million gallons a day with a peak of about 66 million gallons a day. When we came out of the drought in 2016 and 2017, our average day production was about 35 million gallons a day with a max of 57. During the drought, so in 2015, our lowest day average production was 32 million gallons a day. The max that year was about 41 million gallons a day. So we definitely noticed a sharp decrease in the amount of water being consumed, and so the amount of water we needed to produce. So as a result of that, one of the decisions our agency made was to temporarily decommission one of our water treatment plants. And we did that for, we anticipate to do that for approximately 10 years, because that was, at the time, our projection of possibly when demands would rebound and we would need that treatment facility. And as you can imagine, that had quite an impact. One of the impacts to our distribution system was that treatment plant provided water directly into one of our larger upper zones. So when we did that, when we decommissioned that plant, it actually increased the reliance on our booster stations from the lower zones. So now, instead of producing water in that upper zone, we had to pump it up to there. And prior to that, those facilities had not really been relied on so much for that boosting. So that led us to a lot of planning changes and some operational changes in our distribution system as far as just managing it and moving the water. Okay, and also, of course, when you close the plant, you're looking at some staff reassignments and operator reassignments. So we had those issues as well. Can we go to the next slide, please? So during the drought, we have here, this slide displays bromide levels, and the following slide is going to display some TOC levels during the drought. So in the driest years, there are 2013, 2014, and 2015. You can see there that our bromides for our surface water plant increased actually quite a bit over their normal. So the red line there is the average. So a normal year average is about 200 micrograms a liter. And we had spikes of close to the 500 level. And our average for that period was much higher than normal. The higher bromides were impactful for us because our surface water plant number 2 uses ozone as to provide its disinfection. And the higher bromide levels can lead to higher bromate levels. So we did put a lot of effort into addressing that. Thankfully, we already had that plant pretty much optimized for bromate control, but we ended up finalizing a predictive model to use for to predict bromate formation to help us kind of optimize the treatment of that water as it was coming in. And then can we go to the next slide, please? Additionally, the high TOC levels. Again, the higher TOCs are very challenging for surface water plants. The top line there in the red is the raw water, so that's the TOC levels coming into the plant. The blue shaded area is where our normal range of TOCs are, total organic carbons. Normally, the range of the South Bay Aqueduct water at our plant influence is between the 2 and 4 level. But during the dry years, we had it at 3 and 4 times that level. And when you get higher TOCs coming in, the lower line there within that green band is your treated water TOC levels. So those increased as well. And that can lead to less stable water in the distribution system, which contributes to water quality challenges. You can get a chloramine decaying and chlorine decay faster with the higher TOC levels in the treated water. So also just higher chemical costs and just a more difficult water to treat for the surface water. So those are some of the challenges that, I should say, the impacts of declining flows during the drought. And then can we go to the next slide? All right. So the next slide, this is our distribution system. So as I mentioned earlier, we have 3 treatment facilities, so 3 primary sources of water. And the shaded areas in that graphic kind of indicate what facilities provide what areas of the distribution system water. And so something we became aware of as flows decreased, like I said, our average coming out of the drought was much lower than starting at the beginning of the drought. So with the declining flows, the way we operate our facilities, in the case for a desalination facility, we generally keep that one at a constant rate or fairly constant rate. And so as we had lower demand, so we ended up reducing the rates at our other facilities, which changed the area of influence. So the shaded areas is essentially the area of influence within the distribution system of that water. So those areas of influence shifted. And this actually is the current area of influence displayed. But prior to that, the orange band around the Newark area was smaller. So as those areas shifted, that changed some of our monitoring locations for compliance sampling, especially for triggered source water sampling, because now some areas are no longer influenced by, for example, the blending facility or our treated surface water plant. They're influenced by our desalination facility. So the changes in demand, also changed I guess I should say the areas of our distribution that had specific water quality. So all the water quality is very similar, but there are some differences in it, and customers noticed that. And also, as this was occurring, as you can imagine, we did get some flow reversals as that water kind of migrated in the distribution system. So that did lead to some flushing. As was mentioned earlier, that's one of the impacts of those flushing programs. We did have to do some flushing. We've also noticed water age. With the lower demand, we have an increase in water age. Of course, we keep our storage volumes a bit lower than we had with the higher demand. So that helps with the water age, total system storage volumes. But again, there's only so much you can lower those storage volumes, and you still need to maintain storage for fire flow and such. So we do get potential water quality problems, and we do get water quality problems due to the water age. That's led us to, we pay more attention to our reservoirs now, and we chlorinate them on a fairly frequent basis. In our distribution system, we actually have 4 automatic chlorine boosting little stations set up. And additionally, the operators have to do manual chlorinations especially for some of our upper zones on the tanks at a fairly regular basis, usually every, sometimes as frequently as monthly. So, okay, and then as I mentioned earlier, we did, so our system, it's not clear here, but we have 12 pressure zones in the system, and some of the zones don't, even some of the large zones don't have any storage associated with them directly. So as we changed, when we decommissioned that water treatment plant, it changed kind of the direction those zones with no storage were filled from. So instead of filling from the top, we had to fill them from the bottom. And that created a lot of demands on our maintenance and our operational teams as far as just making the adjustments on the system with the regulators and with the booster stations to account for that difference in the way water moves. All right, if we go to the next slide. So we had some other takeaways from declining flows. So our first one is conservation efforts were more effective than we anticipated. So we initially asked for a 20% water use reduction, and our customers stepped up and provided it. And additionally, the following year, they conserved another 10%. So that was good, but it was definitely more conservation than projected. That did lead to some revenue impacts. Our revenue kind of suffered. As far as costs go, a high percentage of our operating costs as a water utility are fixed. But a low percentage of our revenue is fixed because of our rate structure. With most of our revenues are from the commodity charge, which is variable. So, and additionally, we have concerns about what we call demand hardening. That's kind of when people become really efficient in their normal use, so which leaves less room for reductions when there is another drought. So just for the number I posted earlier, as far as our demands that was coming out of the drought was about 34.8 MGD. Since then, so the following 2 years, demand increased to 37 MGD and then remained flat. And then this year, it looks like it's trending up to somewhere close to 38 million gallons a day, but still, we're nowhere near where we expected to be. We had kind of anticipated that demands would rebound at a rate of about 5% per year, and they have not. The demand rebound rate has been between 2 and 3%. So definitely a lower rebound than we're anticipating. And then as a result, our planning group is going to be probably adjusting the way they do demand forecasts. Because like I mentioned, initially our demand forecasts we anticipated the rebound of about 5%, and we only got between 2 and 3. All right, that's all I have. The next up is going to be Eileen, who will talk about the wastewater side.
Great. Thanks so much, Mike. It's great to hear from the water side perspective. And I can relate because I was running the water system during the last drought. But now we can kind of flow into wastewater, kind of the whole water circle before we go to Florence with recycled water. I think a lot of you know that EBMUD has one main wastewater treatment plant located at the foot of the Bay Bridge. And right now we serve almost 700,000 customers, and we're projected to have 1.1 million customers by 2050. Our average day production now is about 53 million gallons per day, and our peaking factor during the wintertime is 14, so pretty significant. So the next slide shows you, basically we're looking at the National Oceanic and Atmospheric Administration. 2019 was the second hottest year on record worldwide. The image on the slide shows temperature around the globe during each month. The red represents temperatures that were hotter than average, while the blue represents colder than average. And then next slide, we're going to hone into the Western United States. The photo on the left compares the snowpack in the Sierra Nevada mountains in February of 2019, and then in February of 2020. I know that February seems like a lifetime ago, given the global pandemic, but you may remember that February 2020 was completely rain-free for the Bay Area, which hasn't occurred since the Civil War. Most recently, it's made headlines that the Western United States may be entering what's referred to as a mega drought. A mega drought is a drought that can last for decades. And in the past 1,200 years, there have been 4 mega droughts. So next slide, that kind of tells us what's the impact. Now that I've set it up that we may be in for more droughts, and you heard from Mike about what the impact on water supply is, the effect on wastewater is very different. So what happens is we see the effects of climate change on wastewater and droughts in particular change people's behavior to save water. And as the girl in the photo shows you, she turns off the faucet while brushing her teeth. During the drought, we've had an increased societal push also through technological innovations like low flow shower heads and high efficiencies appliances. And then we also see an expansion of recycled water, which Florence will talk about. All this adds up to significantly decreased wastewater flows. And I'll show some data in a moment. But even though the flows are reduced, the same number of people still live in the community though and generate the same amount of waste. So as a result, what we're seeing is the strength of the wastewater increases. In other words, the concentration of the chemical constituents like biological oxygen demand increases. Increased wastewater strength can cause biological upsets in the secondary treatment processes. What's more, when the flow is lower, the wastewater travels less quickly in pipes and takes longer to get to the wastewater treatment plant. And as we know, stagnant wastewater without oxygen can produce hydrogen sulfide, the chemical otherwise known as rotten eggs. So hydrogen sulfide can worsen odors and accelerate the corrosion of sewer pipes. And we did see during the past drought, we had an increased number of odor complaints within the wastewater service area. During the past drought, we were fortunate to not really experience any biological upsets within our plant, and we were able to comply with our NPDES permit. Thus, it's likely because we're a large agency with high flows, we didn't see the number of odor complaint increases as significantly as we heard some of the smaller agencies experience. And then the next slide shows our changing wastewater flows. This slide shows the annual dry weather flow rate over time. You'll notice that over the past 20 years, our flows have decreased noticeably due to water conservation, despite the fact that our population continues to grow. So if you look back in the 1990s, our flows were closer to 80 MGD. We dropped down into the drought period to less than 50 MGD, and now we're back up just slightly above 50 MGD. And this all relates to the water conservation efforts that Michael was talking about in his presentation. And so then we ask our question, and the next slide shows, where is wastewater flows going in the future? Where we see our flows going, right now we're in the middle of a comprehensive master plan for the main wastewater treatment plant. One of the main drivers is capacity. And over the next 30 years, our population is expected to increase from about 700,000 today to 1.1 million. Even with the continued sustained water conservation, we'll reach a point where our flows creep back up again. They're not going to stay at today's rates. By 2050, we predict that our flows will have increased from about 53 MGD to 73 MGD, which is still less than what we were, our flows were back in the early 1990s, which is pretty remarkable. This is good news for us because it means that we do not have to expand the capacity of our treatment system to manage the flows. And then the next slide shows the changing wastewater influent loading, and we'll continue to see an increase in the influent loading as well. This graph shows the total suspended solids projection. However, we're fortunate that our main wastewater treatment plant was designed when there were many canneries within our service area. And so as a result, the design loading of our existing treatment plant is already high. So we're not expecting to have to make changes for the flows and the change in our influent loads over the next 30 years. There is other things that we're going to have to address, such as nutrients and our aging infrastructure, and address climate change and how do we balance that with our resource recovery program, and looking also at sea level rise. And that leads us kind of to our next slide, which is really taking a multi-pronged approach for the future. This graphic summarized our multi-pronged approach to climate change, which includes really 4 main items: adaptation planning, resource recovery. You know, when our plant was built back in the 50s and secondary treatment was added in the 70s, it was all about focusing on protecting the environment and public health. But now, especially with climate change, wastewater plants are now looked at resource recovery centers. And we look at where can we take our biogas and create renewable electricity? Where can we use that biogas to create renewable transportation fuel? How can we use our nutrients for fertilizer? And how can we make beneficial reuse for our biosolids? So we're integrating all this into our master plan to create a roadmap for the next 30 years. The roadmap isn't just a straight line to 2050, I should be clear. It's an adaptive plan. And given the various uncertainties, the roadmap has different off-ramps for different scenarios or triggers. So, and now's the time for us to plan. We're fortunate, we're not going to be impacted by sea level rise for many decades, but we don't want to wait until 2050 or 2060 to start planning. Since it's a regional problem, it requires regional collaboration, and now's the time to start planning. And then this is just a nice segue to Florence as we look at reusing all the different components of our wastewater influent. One of the things we do is we make use of our recycled water at the plant to like water our landscaping and for other purposes. And Florence is going to next talk about our recycled water initiatives at EBMUD. Thank you.
Thanks, Eileen. So before I start talking about the effects of the declining flows on our recycled water system, I just want to give you a little bit of history about our recycled water program. So we started in the 1970s with in-plant use. And then by the 80s, we added some landscape irrigation projects, including providing secondary effluent to the Richmond Country Club for their golf course irrigation. And then in the 90s, we completed our very first recycled water master plan, which gave us a goal of using 14 million gallons of recycled water per day by the year 2020. And then we also entered into a partnership with Chevron Refinery to provide recycled water for their cooling towers in 1996. And in the year 2010, we had another agreement with them to provide boiler feed water to them. And then in 2012, we updated our master plan again, and we increased our goal from 14 to 20 million gallons per day by 2040. And then most recently in 2018, we updated our recycled water master plan again, and we considered both non-potable and potable reuse in that study. Next slide. So our current program, we actually have 5 non-potable projects. And we've spent about $280 million to date is what we've invested in those projects. And of those projects, we have 4 of them require us to have a partnership with another wastewater agency to provide our supply. So the East Bay Shore project, that's the only project, that's the one that's located at our main wastewater treatment plant. And that's the only project that we don't require a partnership for supply. And let's see, next slide, please. So right now with our current projects, we're nearly halfway to our 20 MGD goal. Our production capacity is 9.2 million gallons per day. And of that 9.2 million gallons, 80% of that serves the Chevron refinery between our 2 recycled water projects, the North Richmond project and the Rare recycled water project. And we rely on our rely on a supply agreement, with West County Wastewater District to provide the supply that we need to serve both of those Chevron projects. Our next largest project that we have right now is our San Ramon Valley recycled water project. And that's an irrigation only project. And we are in partnership with Dublin San Ramon Services District for our supply to serve our customers. So although we have the 5 projects, I want to focus on how the declining flows have affected the 2 Chevron projects and the San Ramon Valley project. Our East Bay Shore project, we've definitely had some impacts from declining flow, but I'll leave that for another presentation. So I'll start off with our North Richmond and RARE projects. As I mentioned, West County Wastewater District provides our secondary effluent to serve both of those projects. And when the RARE project came online 10 years ago, it was assumed that the West County supply would be able to serve both North Richmond, RARE, and 35% of the irrigation demands for the Richmond Country Club, so they could irrigate their golf course. We also thought that the West County supplies would increase over time so that we would be able to provide the Richmond Country Club with up to 65% of their demand. But we haven't seen that. The flows have actually decreased over time. So in this graphic, you can see just the average flows of that. The dark blue line shows the average flows coming to West County, and the light blue line shows what we need just to serve North Richmond and RARE. There you go. So you can see that area that's colored in. Those are the 6 months out of the year where the supply is not adequate to serve those two customers. So we're not currently serving the Richmond Country Club anymore. We're just trying to serve the two Chevron projects. And we're looking at some creative ways that we can meet the demand. So some of the strategies that we have right now is because we don't have enough supply during those peak summer months between, well, summer and fall, between April and October, we have to supplement with potable. And that's a requirement of the agreements that we have. We need to make sure that because it's an industrial customer that they have a constant supply of water. So we're looking at some ways that we could possibly supplement those supplies. One of them would be partnering with the city of Richmond with their water pollution control plant. But there are some challenges with that option. That plant would require some major upgrades, and the way that their plant is situated, they have some constraints on site, and there's little space for new treatment facilities. The other option that we're looking at is evaluating waste streams from the district's Adeline and North interceptors to determine if they can be used as a suitable alternative supply to East Bay Shore to produce reliable, high quality water. And then we can supplement that at our North Richmond facility. So those are some of the strategies that we're doing for those projects. So let's take a look at the San Ramon project. So the San Ramon project, as I mentioned earlier, it's a partnership with Dublin San Ramon Services District. And all of East Bay EBMUD's customers are irrigation customers for this project. And although growth has occurred, a recycled water supply has not kept up with the anticipated growth. And you can see from this graphic that the projected average dry weather flows by 2019 were expected to be 18 million gallons per day. But in actuality, they're closer to 10.4 MGD. So that's a pretty big difference of what was anticipated versus reality. It's about 7.6 million gallons per day. So in order to meet peak demands, supplemental supplies are going to need to be secured. Next slide. So we're looking into several different strategies for this particular project, including potable water addition during peak demands. And that's an option that's, it works well in non-drought years, but in drought years, it can become problematic. We're also looking at demand management, which could be voluntary or mandatory cutbacks for our customers, shifting the timing that some of our big users would be using the water, and then possibly changing the pricing to reflect the scarcity of the water, and also as a last resort, switching some users back to potable water. In anticipation of future shortages on this project, there's currently a connection moratorium. And so having said that, we're kind of looking into some other options. Some of them are more short-term and temporary, and some of them are long-term. So one of the projects that we are looking at to provide additional supply to our customers is an agreement that we have with Central Contra Costa Sanitary District, where we can divert some of their flow and send it back to DSRSD's treatment plant to increase the supply there. We're also looking into the Livermore connection, and then also groundwater pumping. The groundwater pumping is an interesting option as well. We can pump, we're looking into a pilot hopefully for this year where we can pump some groundwater and send it back to the DSRSD treatment plant to increase the supplies during those months where there is a shortage. And then some other options include groundwater storage, and then we're looking into other options. So those are all, you know, different ways that we're trying to cope with the impacts of declining flows. But just in conclusion, I would say that, you know, the demand for recycled water is growing. The wastewater flows are less than projected when these projects were planned, and many of them were planned, you know, decades ago. So there's been a lot of change since they were planned. And although potable water addition is viable, we would only want to use it to meet peak demands, and it's definitely not a long-term solution, but it's something to be considered. And supplemental supplies will continue to be a focus for all of our recycled water projects, except for East Bay Shore. So with that, I will turn it back over to Katie.
Yeah, and thank you all. Dave, have you been monitoring the chat? Are there any questions that have already come through?
Yes, I have. And we have a question from one of our guests, Harold Mantle, has a question for Eileen White. Eileen, you mentioned that H2S attacking concrete wastewater pipes is occurring, and how is East Bay MUD addressing this issue? Is there a program to replace with type 5 H2S resistant concrete pipe?
Right, so as part of our regional consent decree that we've entered into with the other agencies, the collection systems, the 7 satellite agencies, we have a program to look at our interceptors and replace them. And this past, actually it was last year, the project ended a year early. We rehabilitated 4,800 feet of our large interceptor. So that's a 9-foot diameter pipeline here in West Oakland, almost a mile long. And what we did is actually, it was finished a year early because we used a slip liner, which we had never done before. And it also minimized the impact to the community. And we slip lined with a fiber cement reinforced mortar. It was called Hobis. And before that, we had used a crown liner, which was a fiberglass material that resists corrosion. So as we look at our interceptor and where it has the most corrosion and we're rehabilitating it, we're replacing it with liners that can resist corrosion better than what was put in the 1950s.
Thank you, Eileen.
Thank you.
So that, Katie, that's the only question that I got during the presentations. I see Bob Whitley has a question. Bob's question.
Just got one from Bob.
Bob says, who would have thought we wouldn't have enough recycled water to satisfy customer demand? So that's a question for the whole group. Katie, how do you want to address that one?
Yeah, it's interesting. It seems like, not sure if that's a rhetorical question, but yeah, it seems kind of crazy. And I know we're seeing this challenge across multiple agencies, at least in the Bay Area. So Florence, it's interesting. I mean, you touched on the different partnerships of maybe there are opportunities to, you know, partner with other agencies who actually do have water available and kind of you look at that water more holistically versus focusing on your individual service area, your individual facility.
I'd be happy to chime in. Let me see.
Yeah.
Oh, I'm happy to chime in, having commented on the Hertzberg bill last year, which I think a lot of you are familiar with. That in concept sounded great, that you take, all of EBMUD's wastewater and you recycle all of it. But the reality and the complexity, having managed our distribution system, which is very complex with 122 pressure zones, is the issue is where the wastewater is doesn't match up with where your water demands are. So for us to take our wastewater at the foot of the Bay Bridge and then build all this new purple pipe and then pump it up into the hills, it's very expensive. And I realized last year with one of our projects in Berkeley, we couldn't even get an excavation permit for a short segment of pipe in Berkeley. So can you imagine taking wastewater from our plant to the foot of the Bay Bridge and then potentially building a pipeline to our largest local reservoir, which is Briones Reservoir with a 60,000 acre foot capacity, and going through Orinda? So I think the complexity isn't even necessarily, Bob, not having enough wastewater, it's having the wastewater at the appropriate place to meet demands and having the quote purple pipe today. I think, in the future with potable reuse, I think then there's more opportunities, but right now having that different distribution pipeline makes recycled water very expensive.
So Dan McIntyre has a good comment here. Potable reuse is the wave of the future. Purple pipe is so 20th century. So to your point, Eileen, it's having to pump the water from the source back to a reservoir is very expensive. And Michael, do you have any thoughts on how potable reuse might fit into the picture for your agency?
So that's it's interesting you said that, because we had our agency had planned to do more reuse than it's currently doing, but we had the issue of the planned customer we had for that didn't end up, I believe it was a golf course, but didn't end up actually building their golf course. So we didn't end up having a customer for it. But the question or the situation that EBMUD's running into with Chevron kind of puts another spin on that. If we do get potable reuse going on and get customers for it, we might end up with a commitment to then provide that, right? And that's an aspect of the reuse that I hadn't, I don't know if we've even thought about that. So I'm going to share that around here to our planning folks.
Yeah, that's very insightful. Aaron Hansen has a question. Aaron, do you want to unmute yourself and ask your question?
Yes, sorry, just trying to find the mute button. Can you hear me?
Yep.
Yeah.
All right. Yeah, I was just wondering, I saw the population projections and flow projections and wondering if any of the agencies are updating those as just to consider potential variations in those from COVID, because we're all sort of assuming population projections pre-COVID, and now if tech companies or other companies are allowing people to work permanently from home, does that impact population in the Bay Area? And maybe that's a question that's larger than a water agency to answer, but just wondered if that's on the radar or anything like that.
I can chime in on that. Yes, it is on our radar. We've been, when the shelter in place started, that was one of the first things we tried to do, was predict update our demand projections. One of the challenges with it was we weren't sure of the duration. Initially, it was projected to be about 3 weeks, and as we all know, we're still in it. So we've seen actually about a 2 NGD increase the last couple of months than we had projected, so over last year. And it's largely because most of our customer base is residential, and that's where a lot of our usage is from. And I think that we got to, at least for our agency, I'm pretty sure we'll need to kind of wait and see where this goes, how long it lasts before we really start implementing those projections into our long-term models.
And then I can answer from EBMUD. We've seen a decrease a little bit in commercial and industrial, but overall our demand, and part of it is, you know, it's been fairly warm. We're not less than last year. Actually, we're a couple MGD higher. But a fascinating fact that entertained my three sons at the dinner table is what we're seeing with the wastewater flows. We're seeing in the diagonal curve, the peaks are shifting. So apparently all these people who are telecommuting are getting up later and using the bathrooms later. And also seeing at nighttime that it's later too, that people are staying up later. So it's kind of interesting when I shared that with my team and my last town hall meeting, they all kind of laughed, all the telecommuters that we're watching you, because it's very interesting. It's shifted several hours, the morning demand, peak demand, and the night peak demand. But so far, I think because we've been in shelter in place, we saw the reduction in the commercial and industrial. And I think, you know, that's a good question that's raised. I think longer term, we'll need to see what really happens. I know Facebook is allowing people to telecommute and move out of the area. And I don't know how much technology we have in the East Bay, but that's a little tidbit from EBMUD's wastewater.
Thanks.
If I could give you a perspective from Central Sand, pretty much parallels what Eileen just said about EBMUD. We haven't seen much change or reduction in flow. Obviously, we don't track the potable water side, but we've seen some shift in the diurnal flows as well.
I'll just add from the recycled water perspective, you know, our largest customer is the refinery, and with the whole shelter in place and people not commuting, they have been using less water at the refinery, which means that we're providing less recycled water to them. So hopefully things will bounce back at when things are, you know, back to normal, but we'll see how that goes.
Any other questions from the group? You can either type in the chat or feel free to unmute yourself.
Katie, it's Marguerite. Can you hear me okay?
Yeah.
Hey, Katie. Yeah, I just thought I'd chime in. CCWD, similar to EBMUD, has seen an increase in demands this year, primarily in our municipal customer base and our residential, obviously. Yeah, we haven't seen, like, we're not really tracking it on a shift basis, but we're seeing demands go up. So just thought I'd chime in. And then on the with the urban water management plans coming up, maybe that's an opportunity where we start looking at Aaron's question for the 2020 plans that come out next year, because that is a really interesting question about shift of institutional, like colleges working remotely, things like that, as well as commercial and industrial. We've also seen one of our major refineries scale back production just due to people not driving. And so we're tracking all these things and watching also revenue. Thanks.
So this is Mike again from Alameda. I just, yeah, I meant to say our demand, we saw a 2 million gallon a day increase over last year. If I said decrease, I misspoke. But yeah, since shelter in places began, our demand has increased as well. And it's due to our customer profile being mostly residential.
This is Aaron again. Yeah, I appreciate the input from everybody. And that's, I guess, different than what I would have thought, just because, but maybe it makes sense if people were commuting to San Francisco or Silicon Valley and now are staying home in communities that are more residential. So I'd be curious to know what SFPC and, you know, Peninsula water agencies, water uses are. But that's a call for a different, or a question for a different call, I guess. So thanks for the input.
Yeah, well, and Aaron, as a resident of San Francisco, I know you are as well. I think sometimes I ask myself, why am I paying rent to stay here if I'm working remotely and everything's closed? So I'm sure others might be having those questions too. And as you said, if telecommuting becomes like a long-term thing, it'll be interesting to see shifts in population along with that.
Yeah.
Yeah, I'm also curious, I know, so the drought now, we keep saying the recent drought, but I guess now it's been 4 or 5 years since the peak of it. And I know afterwards, having some wet years, it seemed like maybe there was less attention around it, and we tend to kind of forget about the drought once it's over. And now with COVID, everyone's attention is drawn away to that. For any of the panelists who want to chime in, do you feel like there's a need to maybe raise awareness about this pending potential mega drought or climate change or other longer term issues? And if so, how are you handling that? I think you're on mute, Eileen.
Oh, I was going to say, for East Bay Med, we definitely, want to be out there doing a lot for climate change. It's something our board, feels strongly about, and our staff. So we definitely want to we're looking at ways, even with part of our master plan, how to reduce our greenhouse gas footprint. I think with regard to the drought for East Bay Med, it's not 1 year, and luckily we're going to start the water year fine. I think because we're already concerned about potentially lost revenue and water demand potentially going down as time goes on, I think at this point we don't want to say anything, but we want to see how next winter plays out, because if it does turn dry, then we may be flipping the switch on our whole drought plan, plan that we have. Fortunately, we have our Sacramento River supply. The Freeport project was completed just in time for the driest 4-year period in the history of the state, 2012 to 2015. So right now, because of the way we're set up, we're fine. We're going into the situation, we're going in almost full next year, but it is something to see. Are we going to be going into a bigger drought? And that, along with public safety power shutoffs, the global pandemic, and the economic crisis, it's a lot, as you said, it's a lot balance. And I think right now our number one priority, as you said, is focusing on the pandemic, making sure we keep people safe, and making sure we have enough operators to operate the water, wastewater system, and then really getting ready for public safety power shutoffs. Our understanding from PG&E, they're going to be a little more surgical this year, and hopefully we don't have as many of them. But I think that, and then we'll see if we get a drought thrown on top of that or something else to throw a new challenge to us.
Great. Mike, you gonna chime in?
Yeah, I think I'd just like to mostly echo a lot of what Eileen had just said. We, the COVID has definitely been a big impact in responding to this pandemic crisis, but we have other crises or potential crises that we're preparing for, right? And are always kind of responding to daily. We want to keep the focus, I think, on the fact that what we do is, providing safe drinking water is necessary for public health, and all of the components that go into that, including preparing for future water quality challenges and water quality regulations, are still important, right? And can't be totally eclipsed or sidelined because of the pandemic response.
All right, I have one other question, and Mike, this might be for you, but on the financial side, I mean, so you're saying demands are increasing, and then that kind of puts pressure on water rates, right, where they might need to be more expensive. And then now with the pandemic and the economy, how are you looking to keep water affordable while still maintaining financial sustainability?
Great question, and I can speak to it from an operational perspective, but not so much as far as I'm not aware of if we're looking at any other kind of rate models or anything. I know we do have low-income programs to help with keeping water, with the affordability of water. But from an operational perspective, we do really keep a close track of our system operations, of our chemical use. We build tools like the predictive model to help optimize our chemical use, which in turn helps keep costs down for the water, while maintaining the water quality. Also with things like the demand projections, I mentioned that we're going to be, we have kind of refined them a bit, or they've been evolving. We put a lot of effort into trying to get those as accurate as we can, because that helps our cost projection to, again, at least do our best to forecast the most realistic costs that we can, so that when that translates into the rate structure, it's more realistic.
All right, any other questions from the group before we wrap up? All right, Lindy, do you want to take it back, or Dave?
Just one final question, Florence. I thought your presentation was fascinating relative to dealing with all the systems, but you mentioned East Bay Shore, and that's maybe a topic for a different day. But did you have you guys felt some effects just in general on recycled water quality at East Bay Shore?
Yeah, I think they're I guess exasperated when we have a drought, and it affects the water quality, the salt contents. It goes up because the waste is more concentrated. So it has an effect on our irrigation customers, and with that high salt content, it affects, how the landscaping thrives. It doesn't thrive as well during the drought times. And then I guess the other impact is, this is just a general water quality issue for East Bay Shore, is the ammonia content in the water and just the ability to serve industrial customers. So that's, I guess, a little bit bigger of a conversation. We're, as you know, we're in the process of seeking proposals so we can work on the water quality issues for our East Bay Shore project, to see what we can do so we can add more customers and not have those same effects for irrigation customers, and then being able to add on more industrial customers.
Yeah, thank you.
You're welcome.
Okay, Dave, does that wrap it up?
That wraps it up. Thank you, Katie, and panelists. That was fascinating, and I think you whetted our appetite for some additional presentations in the future. And I especially struck with Florence's presentation on what's happening out in Dublin, San Ramon, Derwa, and the searching for additional supply, thinking about groundwater and groundwater storage. So perhaps a topic for another presentation down the road, Gary.
Yeah, thanks, Dave. And yeah, again, thanks, Katie, Eileen, Florence, and Mike. What a great presentation. We had 41 participants today, so a great crowd. I also wanted to highlight next month, our meeting in July, we're going to have Nancy Vogel, and she is the director of the governor's water portfolio program. So it's a very high level position. So get your questions ready. That should be a great presentation. So I look forward to that. So, since the last time we met, COVID-19 was top of our mind, and certainly we've learned a lot. And Eileen, again, thank you for such a great presentation on what the wastewater industry might offer related to the science. Since then, our country has really moved into a huge social debate related to policing, and that triggered by the killing right in front of our eyes of George Floyd. And so there's a lot of heavy duty conversations going on out there. And I think our job in the water industry is to quietly continue to do a great job and keep the public's confidence level high in what you're doing. So thank you, and thank you for a great job. Talked a little bit about the drought. We're in pretty good shape this year from a water standpoint. There is a water bond that may end up on the November ballot, so I encourage you to take a look at that and be involved. And then on a more lighter side, I also, like last time I reported out the use of alcohol, during this pandemic period, that the statistics show a 49% increase in alcohol sales. The same survey indicated that up to a third of the men that responded are admitting to daytime drinking now. And my wife overheard that conversation last month. And so she asked me, I said, Gary, are you part of that, 30%? I said, absolutely not. I don't start my cocktails till 5 in the afternoon. And then I recalled one of my favorite singers out there is Jimmy Buffett. And, it's 5 o'clock somewhere.
Yep.
So not me. Anyhow, I turned that back, turn it back over to Lindy, and have a great month, and look forward to seeing you guys in July.
Be safe, everybody.
Yeah, thank you, Gary. And thank you all for joining us. Katie, I really appreciate your assistance in organizing this. And to all of our panelists, thank you for being part of it. It was really informative. This has been recorded, so if you have anyone you want to forward it to, it will be available to members through our member portal on the website. And if it's okay with our presenters, the presentation will also be available on the website. I did want to mention the East Bay Leadership Council does a leadership series every year. We have been in the planning process of our third part of that series. The second part had to do with housing. That is also available if anyone is interested. But we're going to be doing the third, and I appreciate, Gary, you mentioning the death of George Floyd. We're going to be doing it really aligned with our chair, Vic Baker's mission this year, which was about equity and inclusion. And it's going to be potentially a training. So instead of kind of more of a keynote like we often do, we're going to be doing something a little bit more hands-on. But just wanted to recognize that there's a lot of people here who work in fields in which inclusion and equity can be a really important part of the conversation as you hire and train. And so just wanting to let everyone know that that's something we're thinking about. If you have input or are interested in that, I really would appreciate you reaching out. Otherwise, please look forward to some announcements about that. We hope you'll join us as we start to have some of these difficult but very, very important conversations about what the business community can do to be more involved in this and to have conversations around anti-racism and anti-Blackness. So thank you all.
Thank you, Lindy.
Thanks.
Thanks, Lindy.
Thank you.
Thank
See you all
you.
soon.
Bye-bye.
All right. Bye.
Bye. Thank you.